Hi, today we're going to look at waves. What I'd like you to do is draw a picture of this wave, and then I would like you to mark what type of wave it is, the amplitude, the wavelength, 2 points that are in phase, a trough, and a crest. Stop the video and write down the answers to it, and then restart, and I will go over it. Okay, going over it. Type of wave, this is a transverse wave. I really like this new color. It's very bright. Okay, the particles move perpendicular, so they are moving up and down, even though the wave is moving left-right. So the particles move perpendicular. The amplitude of the wave is from equilibrium up or down. Remember, they are exactly the same, but it's just from equilibrium. Wavelength. A wavelength is the whole wave, so it's from where a wave starts to where the next wave starts. So it includes a crest and a trough. So 2 points in phase are 2 points in integer wavelength. So let's say it's this point and this point. They're in phase, but I could also say it's this point and this point because they are an integer wavelength apart. The trough of the wave is down here at the bottom because a trough holds water for horses, and a horse could drink out of that. And a crest is right up there. Okay, the other type of waves are longitudinal waves. They move parallel. So they are going to move left-right. So they move that way. And then we got a definition. The pulse, remember, it just moves energy, not material. All right, our next slide. We have frequency. A long time ago I said I'd memorize one of these definitions. So frequency is waves per second. It's measured in hertz, and its inverse is period. Now, you could also memorize period. That is seconds per wave. That's measured in seconds. The equation is this. F equals 1 over period. And then I just put in a couple little hints for you. Frequency is based on the source. So once we create a wave, the frequency isn't going to change. And then period and frequency are inverses of each other. So I could write this one, or I could write this one. Then I have this problem. V bar equals d over t. And I want you to try this guy here. We have a sound wave, and it's going to take 2 seconds from your yell to you hearing the echo. So how far away are you standing from the wall? So stop the video, solve the problem. All right, we have an echo. So we got our person, they're yelling, and an echo means the sound's going to bounce back. So if my equation is V equals d over t, and I know that it takes 2 seconds for me to hear the echo, I know it only takes 1 second for it to go to the wall. So now I know the time is 1 second. I'm looking for d. Well, what's the velocity? Well, the velocity of sound is 331 meters per second. Now, if you don't remember that, that's not a big deal. It's on the front page of your reference table. So the wall is 331 meters away. The next problem, or equation I'd like you to try first, is V equals F lambda. So V is for velocity, and that's meters per second. F is frequency in hertz, and wavelength is in meters. Then I put another reminder. Velocity is based on the medium. If we don't change the medium, the velocity is not going to change. All right, so this problem, I have 2 waves that pass every 4 seconds. If the velocity of the waves are 6 meters per second, calculate the wavelength. So try that problem. And I'm going to solve it this way. I have my frequency, and I mentioned I want you to memorize a definition. So I have frequency is waves per second, and I have two waves that pass every 4 seconds. I have two waves every 4 seconds, so I know my frequency is 0.5 hertz. And then I have my velocity is 6 meters per second, and I want to calculate the wavelength. So I could use V equals F lambda. I know my V is 6 meters per second. My frequency is 0.5 hertz. I'm solving for wavelength, and I get my wavelength to be 12 meters. Okay, the next one I want you to try. I got all these lovely drawings. I have a wave coming in, and it's bending. So write down what that is. Write down what the second one is, the third one, and this beautiful drawing of a prism. Okay, we've got the first one is going to be diffraction. Remember, it bends the best if the opening is about the same as the wavelength. That's how you're going to get the best curvature. This next one is refraction. I wanted to write a couple other things. I want you to remember that this is, Snell's law. So N1 sine theta 1 equals N2 sine theta 2. And if you need the index of refraction, they're usually on your reference table. And remember, we also measure our angles from the normal. That seems like the biggest mistake I see. And the other one with this is if we want to figure out its new velocity as it goes into the new material, remember this one, N equals C over V. And C is speed of light in a vacuum. Okay. A third one is reflection. Big thing to remember for that is the angle of incidence is equal to the angle of reflection. Angle in equals angle out. And that would be like a mirror. This last one is dispersion. And that is taking your white light and separating it into all the frequencies. Next, I just rewrote the little hint that I gave you before, that velocity is what the wave travels in, velocity depends on the medium, and frequency is based on the source. I added, if the frequency doesn't change, the period doesn't change. That's helpful for multiple choice questions. When they list both of them, if one changes, the other one changes, so typically it's not an answer. That's just a test-taking hint. And then this awesome drawing is the Doppler effect. So we have the source coming towards the person. The waves are getting compressed. So if the wavelengths get smaller, the frequency is going to get larger. That's Doppler. Doppler does not affect loudness. No. If I'm screaming at you and I'm right in your face, yeah, it's going to be louder. That's not Doppler. Next phenomenon is resonance, the natural frequency. That's things like the singing wine glass, the screaming rod that we used, things that make the material resonate or vibrate. So what I'd like you to do is try this problem here. We have light that has a wavelength of 6 times 10 to the negative 7. What's the frequency or color of it? So what we are going to do is we have our velocity is 3 times 10 to the 8th meters per second. And my wavelength is 6.0 times 10 to the minus 7th meters. We're going to use our equation B equals F lambda. B equals F lambda. And we get my frequency to be 5 times 10 to the 14th hertz. So then I want you to know, well, what type of color is that? Well, you need your reference table, and on page 2 of your reference table, there are a bunch of the colors in the electromagnetic spectrum. Now remember to look up color or type by frequency. So of the electromagnetic spectrum, that's the bottom set of numbers. And look up 5, and I have that to be orange. And then my last question I wanted to ask you, what's the velocity of a radio wave? Take a moment, write it down. All right, a radio wave, if we look at that electromagnetic spectrum, it appears on it. Now remember, everything in the electromagnetic spectrum goes the speed of light. So it is 3 times 10 to the 8th. I might have tricked you. I hope not. Alrighty, you have a good day.